Welcome to Research Fundamental modules, the NICER course 1. Today we are going to talk about some aspects of sampling methods. See, sampling is really required whenever you are dealing with a very large population and you want some quick information. Now, look at the definition of sampling. The sampling is a procedure by which some members of the population are selected and they are supposed to be the representative of the entire population. See, if you have a population of people like this and you are looking at a portion of them, and that is called a sample. I would like to rather introduce you to some concepts, and one of them is the study population. What do you mean by study population? The study population is the population to which the results of the study are to be inferred. Say, for example, how many injections do people receive each year in India? The study population in this case is the entire population of India. Suppose your research question is, how many needle sticks healthcare workers experience each year in India? Then the study population becomes healthcare workers of India. Suppose if your study question is how many hospitals have a needle sticks prevention policy in India, then your study population in this case becomes all hospitals of India. This sample which we select should be representative of the population for which we require an answer. And this representation should be in accordance to the seasonality, the day of the week, the time of the week, whether it is urban or it is rural, or it should rather match the composition of age, sex and other demographic characteristics of the population. See, now let us rather introduce you to some concepts or terminologies that are often used in the sampling parlance. What do we mean by sampling unit? Sometimes it is called basic sampling unit, BSU. These are the elementary unit that will be sampled. That could be people or healthcare workers or hospitals, as we had seen in our example. What do we mean by sampling frame? The sampling frame is a list of all sampling units in the population. And what do we mean by sampling scheme? The sampling scheme is a method used to select sampling units from the sampling frame. So, now there are different ways how or why we should rather do the sampling populations. If you have enough resources, you can probably study the entire population. But still, even if you have the resources, it is not wise to study the entire population, because often the population is very large, and a large population, when you are going to rather collect information, one of the major constraints could be the time. You may require a lot of time to collect information, and you may say, I will employ a lot of people to do that. But what would rather probably happen is, if you have lots of people collecting information, there could be a lot of inter-observer variations which could rather add on to a tremendous amount of error, and unfortunately you cannot measure the amount of such errors. So, it often rather happens that by doing a sample survey, you often get accurate information. The information that you get from sample surveys are more accurate than the information you do on a large scale population studies. So, a population could be rather in an entire universe, whereas a sample could be selected in small regions. Now, let us look at a practical example. Suppose the Ministry of Health of a country X wants to estimate the proportion of children in elementary schools who have been immunized against childhood infectious diseases. You could just rather imagine, the proportion of children of all elementary schools who have been immunized against childhood infections of a country. So, that is the task, but one of the conditions that he has put is the task must be completed in 1 month. So, the objective is to estimate the proportion of immunized children, and you want the results in a month's time. Now, let us rather look at the different ways how you can rather get this information, or in other words, what are the different types of samples that could rather good. See, broadly speaking, the sample could be a non-probability sample or a probability sample. What do you mean by a non-probability sample? This non-probability sample is the probability of being selected, that is a sample, the probability of being selected for your study is not known. It could be a convenient sample, a purposive sample. You just rather convenient, whatever the region that is convenient to you, close by to your place, you can rather go and rather see first 100 people that you come across. That could be a convenient sample. What could rather happen? That sample could be biased, or it can rather give either a best or a worst scenario. People rather know it's a convenient location. You may get the results very different from a location which is not very convenient or which is very remote and difficult to approach. And also, some of these are all very subjective samples, and to derive some objective criteria from a subjective sample is always rather difficult. Okay? But nevertheless, these sampling non-probability sampling methods still are useful, and that are being extensively used mainly to generate hypotheses or to prepare for more systematic probability samples. Now, let us rather look at what do we mean by probability samples. In a probability sample, every unit in the population has a known probability of being selected. What is the advantage? This is the only sampling method that allows to draw valid conclusions about the population. It removes the possibility of bias in selection of subjects and also ensures that each subject has a known probability of being chosen. It allows application of statistical theory, because many of the statistical tests that you do, it insists on a random sampling, and these tests are valid only if the samples are a random sample. Okay? I would like to rather introduce you to a concept called sampling error. No sample is a perfect mirror image of the population. Always, when you pick a sample from a population and when you look at the results, it may not be exactly the same as the results in the population. But fortunately, the magnitude of error could be measured in terms of probability in the case of probability samples. So, this is expressed by standard error of mean or proportion or differences, and that is a function of the sample size and then the variability in the measurement. So, sampling error is a very important component in sampling theory, which helps us in identifying the sample size and things so on. Now, let us look at some of the popular sampling methodologies that are employed in sample surveys. Let us rather look at the first simple random sampling, which is, as the name suggests, it is a very simple sampling procedure, very easy to understand, in which every individual sampling units have got an equal chance of being included into a sample. How do you do that? We number all the units and we randomly draw units. So, the advantage is, as I mentioned, it is very simple, and sampling error is also very easily measured. Major limitation of this is you need to have a complete list of all units. Many times it may not be available, and also sometimes you may get a sample which is very different from the whole population. May not be very representative of the population. See, an example of a simple random sampling could be if you have the list of all, say about these 48 names, you pick a random numbers of 9, 18, 32 and 40. So, these are all the names that are selected as your sample. Now, the next sampling type is a systematic sampling. Systematic sampling, what is rather done, it is initial sampling unit is picked by random, and then every kth unit from that, from your population, are examined. So, a unit is drawn and every k units and every equal chance of being selected for each of the unit. So, you calculate the sampling interval called k, which is divided by n divided by the number of sample size that you require, and you draw a random number which is less than or equal to k for starting, and draw every k units from the first unit. What are the advantage? It ensures representativity across the list. It's easy to implement. You give a worker that you say you start from this house, and every 10th house you go and rather see and cover all the houses. It's very easily it's been done. If there is some sort of a cycle of some specific characters that you are studying, then you might probably get a sample which is very atypical in systematic sampling. And also some of the statistical measures that you are going to rather compute, it's difficult when you are going to rather have systematic sampling where you do not rather have exact formulas, you may have to rather use some approximate formulas. The example of a systematic sampling is you see in the first, the red house is selected, and then every 8th house from that is rather selected, and this is your, all the red houses in these houses are your selected samples. There is a sampling method called stratified sampling. The principle of it is to classify population into homogeneous subgroups which are called strata, and you draw sample from in each strata, combine the results of all the strata to get an idea of the whole population. So, the advantage of it is it's more precise if variable associated with strata, and all subgroups are represented, allowing for separate conclusions about each one of them. Suppose a natural strata could be male and female. So, you have an estimate for male and you have an estimate for female, and you can have an estimate for a combined male and female for the whole population. But the disadvantage is sampling error is difficult to measure, and that could be loss of precision if you are going to rather have a lot of strata, and for each strata you have small numbers in it. Okay. An example of a stratified sampling is suppose if you want to rather estimate the vaccination coverage in your country, one sample drawn from each region, north, east, south and west, and the estimate calculated for each of the stratum, and then at the end you can rather weight the stratum according to the estimate the size of the regions. Okay. So, another important type of sampling which is very popularly used and very in the health surveys in research is called cluster sampling. The principle of cluster sampling is that a random sample of groups or a cluster of units, and all or proportion of units are included in the selected clusters. Say an advantage is it's simple, we don't require a list of units, and less of travel or resources are required because you are going to rather collect a cluster and you are going to rather see only within the clusters. And the disadvantage is if the clusters are homogeneous, then you may have to rather it may result in a large design effect. All the people in the sample may have very homogeneous results, which could rather result in a design effect, and sampling error is difficult to measure in a cluster sampling. The sampling units is not a subject, but a group or a cluster of subjects. The assumptions here is that variability among the cluster is minimal. The variability within each cluster is what is observed in the general population. So, now how this cluster sampling is done is usually it is done as a two-stage approach. In the first stage, a probability proportional to size, that is, select the number of clusters to be included, compute a cumulative list of all the population in each unit with a grand total, divide the grand total by the number of clusters and obtain the sampling interval. Choose a random number and identify the first cluster, add the sampling interval and identify the second cluster, and so on. And by repeating the same procedure, identify all the clusters. Okay. Once your clusters are identified, then in the second stage, in each cluster you select a random sample using a sampling frame, because as I had rather mentioned to you earlier on simple random sampling, when you want to rather do a simple random sampling, you need to have all the list of your sampling frame. So, in a small cluster it is possible for you to formulate the sampling frame, and you can rather select people from that sampling frame on a random basis. Another important sampling methodology that is often employed is called a multistage sampling, and in this multistage, especially in a very large, suppose you want some estimates for at the national level, you need to rather do sampling in several chain samples, and several statistical units are there. The advantage is there is no complete listing of the population is required, and it is most feasible approach for large populations. Okay. The disadvantages is there are several sampling units, and sampling error at times it is very difficult unless you follow certain very specific methodologies for selecting at each stage. Some of the key issues that I would like to rather bring to you up is we cannot study the whole population, so we sample it. Whole population studying it could rather result in inaccurate results. So, the taking sample leads to sampling error, but which is easily measurable, and we do not have a measure for non-sampling error, whereas we have a measure for sampling error. Good design and quality assurance ensure validity, and appropriate sample size will ensure precision. So, the probability sample are the only one that allow the use of statistics as we know them, and so it is always advantage to use a probability sample, so that you can rather have a valid conclusion, a precise conclusion, and also you can employ statistical test on them. Thank you so much.